Today we will learn about the adhesion to metal surfaces, how adhesion acts or plays its roles to different metal surfaces. Now we know that the surface tension of a clean metallic surface, usually metal oxide, it is higher than that of any coating. In other words, we have learned while we were studying about the coating that the surface tension of the coating should be lower than the substrate on which it is applied. But when the substrate or the metallic surface is contaminated with oil or dust, then its surface tension becomes low as compared to the coating, due to which it should be cleaned properly or wiped off with wet rag or using a solvent. Now, a more effective method for the cleaning of such metal substrate is called as vapor degreasing. Now, this process of vapor degreasing actually is the one in which the object is hung from a conveyor belt, as you can see in this figure on the right hand side. Actually, there is a conveyor belt at the top and the object is hung at from the conveyor belt that comes into a tank above a boiling chlorinated solvent. So we have a solvent which is continuously being boiled off, and usually we take the chlorinated solvent. Now the steel surface, the object that we have hung over this liquid, is the steel. So the cold steel surface act as a condenser for the solvent molecules which evaporate from the boiling liquid and get condensed on the surface of the steel, where in this process it dissolves the oils which were present on the steel surface, thereby cleaning the surface. Now the solution drips off, removing the oil. Usually surfactant solutions are used to clean the oil from the metals. So this is vapor degreasing. That means with the help of vapors, we degrease the surface, we remove the oil contaminant from the surface, and in this process some dirt and dust also gets removed. And you in the figure also you can see the saturated vapors are moving up and it's being condensed on the surface, and the distillate moves down. The vapor degreasing process that we have just discussed actually gives a good adhesion, but it gives mild enhancement in the corrosion protection. So when good adhesion and corrosion protection with a relatively smooth surface is required, then the metal surface is commonly cleaned chemically with the help of chemicals. The treatment for the steel are known as conversion coatings or the chemical pre-treatments. As you can see over here, conversion coatings, actually generally it is called as a process wherein the conversion takes place on the surface of the substrate into a corrosion resistant and easily bonded coating. So you can see a metal surface, that is a magnesium substrate on the left hand side, and the atoms or molecules from the chemical solution are being dropped, or let's say sprayed over this surface or applied over this surface. Now what happens, the chemical bond formation occurs between the magnesium substrate atoms and the chemical or the solution which we are using or applying on the substrate. So a chemical conversion coating is formed. Finally, the conversion coating layer you can see as a colored layer on the surface of the magnesium substrate coated with the conversion coating. Now, a variety of conversion coatings are used which are phosphate based. Now, this conversion on the substrate occurs through a chemical reaction which results in the protective coating. The chemical conversion coatings, these are basically become the backbone of many industrial processes, because these coatings are formed through a chemical reaction between the metal surface and the solution containing specific compounds. Now, the reaction produces a thin layer of adherent metal oxide or other compounds which actually enhances the properties of the metals. The coatings that work by changing the metal surface in this manner, usually the inorganic coatings. And yes, of course, there are also another type of coating which is called as the organic conversion coatings. The organic conversion coatings, they involve chemical interactions of resin molecules. These molecules undergo processes like condensation, polymerization, which can be addition polymerization or oxidative polymerization, due to which a cross-linked network is being formed. Now, this network solidifies into a strong protective film. Just imagine like a spider weaving an intricate web only here on the surface, and the web is a durable protective shield covering the metal. So that is also called as the conversion coating. But yes, of course, since resin is used here, so we call it as organic conversion. Now there are different advantages and disadvantages of the conversion coatings. Like for example, it provides excellent corrosion resistance. It enhances the adhesion of the paint to the substrate. But on the other hand, it may require precise control of application process, and sometimes it also involves hazardous chemicals, which are the demerits of conversion coatings. So the two types of conversion coatings that we just mentioned, which are the organic conversion coatings and the inorganic conversion coatings. And remember, the organic conversion coatings involves a resin molecules which react and form a cross-linked solid film on the substrate surface, whereas the inorganic conversion coatings involves a metal surface reaction form oxides or mineral compounds. Like for example, the organic conversion coatings are the radiation cured coatings, the air drying coatings, and the inorganic conversion coatings are those chromate coatings used in automobiles, the phosphate coating, the zinc phosphate coating. Passivation is also an example of inorganic conversion coatings, or phosphating, like zinc phosphating is an example of inorganic conversion coatings. So, organic and organic conversion coatings, and yes, of course, the organic conversion coatings have the advantage of providing aesthetic appeal and flexible application with excellent protection. Whereas the inorganic conversion coating, they offer excellent corrosion resistance and durability. Variety of conversion coatings which are inorganic have been used, like the one which involves phosphate, also called as phosphate based coatings, conversion coatings. One such coating involves the spray or the immersion application of phosphoric acid based chemical compound, which is iron phosphate solution. So the process in which the iron phosphate solution is used, that method actually involves etching of the surface of steel and the precipitation of ferrous ferric phosphate monolayer. So what happens when the iron phosphate solution is used and the substrate is subjected to this type of solution? So a mild etching of the surface of the steel takes place on its application, and the formation of a precipitate occurs, which is having the composition as ferrous ferric phosphate monolayer. Now, this helps in increased adhesion of the coatings and slight increase in corrosion protection. So, in this case, corrosion protection and adhesion both are achieved, but yes, we get a better result in terms of adhesion as compared to the corrosion protection. So if we want to have or achieve enhanced adhesion plus corrosion protection also with it, a better result for corrosion protection along with adhesion, then the steel object is to be immersed in a bath of zinc acid phosphate solution, and we call this process as zinc phosphating also. Now let's try to understand this process. So when we try to study the zinc phosphating, we come to know that a co-precipitate of zinc and ferric phosphate is formed on the steel surface. Now remember, when iron phosphating was done, that involved the precipitation of ferrous ferric phosphate, wherein a monolayer was formed of ferrous ferric phosphate. Here zinc is there, so a co-precipitate of zinc and ferric phosphate is formed on the steel surface. So these are the two chemical reactions wherein zinc and phosphate, in the presence of water or moisture, they are reacting to form Zn3PO4 whole twice, which is hydrated and is called as hoplite. It appears as a mesh of crystals which adheres tightly to the surface and increase the surface area on the microscopic scale. Now, depending on the concentration of zinc in the treatment bath, different crystals can be deposited. If we have a relatively high zinc concentration, then the crystals are predominantly hydrated as in equation number 1, and the product which is formed is called as hoplite. For less concentration of zinc, or let's say zinc starved conditions, the crystals, they are of phosphophyllite, Zn2FePO4 whole twice with 4 molecules of water. So equation number 2 stands when the zinc concentration is less, and equation number stands wherein the zinc concentration is high. The performance of conversion coating is greatly affected by the uniformity and the degree of surface treatment, to what extent the surface has been treated. Now, zinc phosphate coatings, they are generally applied in the range of 1.5 to 4.5 grams per meter square. But if you want to achieve minimum dwell time for the treatment along with high rate of reaction, if we want the product to be formed at a higher rate and taking lesser time duration, then the pH, the temperature and the time variables should be controlled properly. So the treatment surface must be rinsed thoroughly to remove any salt which is soluble, because these salts can lead to blister formation also later on. So when the water vapor permeates through a coating film applied over the soluble salts, it is found that rinsing helps in removing loosely adhered crystals, but the last rinse should contain low concentration of chromic acid so that we can protect the against corrosion. One thing to be mentioned over here, now due to the toxicity of chromium 6, which has proved to be a carcinogenic, chromate rinse has been replaced. That means chromic acid is not used, and instead of that we use 0.5 percentage of methyl trimethoxysilane, which is sufficient to give a pH of 4 for better performance than a chromic acid rinse.